All right, so think functional. There are two ways that you could get to the project. One is, oops, not strings and files, chapter 7, dictionaries and sets. The way I structure the chapters, most every chapter anyway, after the first couple, has a suggested project. So the suggested project in this case is the Gradebook Project. And the reason why it's the suggested project here is that the data type that you would use to store the data that you'll read out of a file, the natural way to do that is with the dictionary. Because, well, it is the gradebook project, and when you think about gradebooks, I mean, they have sort of natural keys and values, right? I mean, the keys are presumably the names of the people in the class, and the values are whatever scores they've gotten. So it seems like the natural data type, so that's why that's here. Also, this is the one project I think that requires that you actually like go into a file and read data out of a file and then write data to another file. So another reason to do it. So I followed the link, and here then is the description of the Gradebook project. Read this, okay? I just went through it again. It seems correct. It seems clear. So I will talk through this, but you should definitely take some time to read through this as well. Okay. So what will happen? Well, you will be given a gradebook. I have given you a gradebook. That link that says here it is, I will follow that link. And I will find myself at a REPL project. And you will find yourself at a REPL project. And I'm the owner of this project, so I cannot fork it, or at least I don't have that screen that has the big fork button on it. You should have gotten that screen if you haven't been here already. If you have and forked it, great. But if you haven't, if this is your first time to visit this page, go ahead and fork it. And then what you've got is this a little bit of sort of sample code to get you started, to remind you a little bit about how it is that you access file and write file data and how you write to a file in Python. And also you will find a text file, data file really, but stored as just text that contains the data that you will analyze. So let's take a look at that initially to make sure that you understand what it is, and then we'll talk about how it is that you'll go into this file and read the data out of it. So first of all, the first row is obviously special. The first row, which begins last and first and then has various categories, tells you how to interpret all the data that comes later on. So it does obviously then tell you that you start with the last name and then the first name, and if you look at the rows that follow, it looks like names. I made these names up a few years back. I think what I had in mind when I made them up is like they would be good names for bad fantasy literature. So for each of these, I had like a character in mind, like a checkered skull as a warrior or something like that. Anyway, and then after last and first, you will find designations like HW, project, and so on. Well, there's only 3 quiz as well. Those are the categories for the grades. Okay? And that matters because how it is you actually compute the average for the class, the semester average, depends upon the categories in which the grades fall. So notice then that that first row tells you what kind of score each score is for each person. So if you look beside Jackman's skull, the first grade is 57. Well, the first grade is a homework grade, the first row tells you. And the next grade is 58, which is also homework. And the next grade is 71, which is a project grade. And the next one after that is 93, which is a quiz grade, and so on. Okay. Now, let me go ahead and say this. When the time comes for me to get a grade for this project, I won't use this same data set. Instead, I'll use a randomly generated data set. It will look like this, but it'll be random. The names will be purely random. I think I actually worked on the name creator so that it couldn't have too long a chunk of consonants. Still doesn't really mean the names are actually pronounceable. I always meant to go back and like figure out an algorithm that would produce names that were at least pronounceable. I don't know how to do that, but I might try it anyway. So it'll produce names randomly, and then some number of grades. And that first row will also be within certain constraints, also randomly generated. It will start last and then first. But as for what the grade categories are and in what order they come, that'll be random. Okay, so don't assume that that first row in this file that I will use to get the grade will be the same. It almost certainly will not be. The first grade might be a project. There might be like 3 project grades to begin. Okay, so what your code needs to be able to do is to respond to that first line. That is, you can't hard code your project so that the first grade must be a homework grade, the second grade a homework grade, the third a project, and so on. Okay, don't do that. Don't make that assumption. Have it respond to what the first row is. Okay. So you'll have to read the file. You'll have to pull the grades out. You'll have to associate the grades with the person. Dictionaries, I think, are undoubtedly the right of the built-in data types to use in this case because, with each person, you've got an associated group of grades, set of grades. So use a dictionary. And then you'll have to perform a computation. Now, as for the computation, which gives the semester grade, let's actually go back to the project description and take a look at the formula. Okay. So here is the formula. The formula says that the semester average is 0.2 times the homework average plus 0.2 times the quiz average plus 0.6 times the project average. I assume that you will use this formula. That also means, of course, that you'll have to actually compute the homework average, the quiz average, and the project average. But that's simple to do, right? You just add up all the scores in the category and divide by the number of scores in the category, and you'll have the relevant average. Then use this function to compute the semester average. And then once you've computed the semester average for everyone, which, I don't know, perhaps a new dictionary or perhaps just a supplemented dictionary, it's up to you ultimately, you'll write your results to a file, like what you see there. So apparently Jekyll Scald has a homework average of 71.57 and so on, through to the semester average. Now, let me point something out about this. Obviously, these are rounded values. In general, if you do this kind of a computation in Python, and then just simply print the result, whatever the value of the variable is, it will have many more digits after the decimal point than that. These have been rounded to 2 digits after the decimal point. And there is a built-in round function in Python, and you can specify the number of digits to which you will round, so you will obviously use that. However, do not round the values stored internally. Okay, my code did not. And my code will be used to generate the file against which your file will be judged. Okay, your file will be compared to my file. I'll discuss that in just a moment how. And it needs to be character for character identical. So you need to do the computations in the same way that I have done. And it seems to me the best way to do it, the way that I did it, is that when you store the values internally, you always store them with as much precision as Python will allow. And then when you print something to the screen or write to a file, at that point, round the value that gets written, but don't actually round the value of the variable. Okay? And the issue here is this, is that if you compute the homework average, and you've actually rounded that value to 71.57, that's how the program stores it internally and then uses that as part of its semester average computation, your semester average computation will be slightly off from mine. And that will matter, okay? Because the way that I will judge your output file is every single character correct? Because I have given, by my examples, a very precise definition of what the output file should look like. And the assumption will be is that you can get that exactly right down to the character, okay? So just as a matter of how you do the mathematics here, don't round within the program. Don't round within your computations. Round only when you actually write a value to the file. Okay? If you do it like that, then our values will actually agree. So this is what you will do. You'll write to a file, and we'll look at some code in a moment that gives you an example of how it is that you can do that. And we'll talk more about this at a later day. But I've also created another REPL that will take your output file and my output file from a randomly generated gradebook, and we'll compare them character by character, and we'll generate a grade based upon that comparison. So the standard will be that your file will be character for character identical with my file. Okay, and that might cause a little bit of difficulty because these are strings ultimately, right? And okay, so there's one place in a line where you leave a space out. Well, that means that when my file does the comparison, it does it in a sort of very, stupid way. It just goes character by character, right? And unless the character in your file is the same as the character in my file, given by position, by row number, and then character number within that row, it'll be judged wrong, okay? So if you leave a space out, after the last name or something like that, or add another space in, the entire rest of the row will be judged wrong. So you have to get all of that correct. We'll undoubtedly like do a trial run or two near the time that this project is actually due, because I think that would be very helpful to you. We'll just pretend like it's the actual day that I get the grade. I'll run the program that generates a random grade book. I'll do my analysis. You'll do your analysis. I will make my file available to you. You will take my file and your file, and you will run my program that compares them, and that will generate a grade. So we'll do that. If you want extra credit, you can also do a little statistical analysis. And the statistical analysis I mean is to compute mean, median, and mode. Okay? Mean is what people usually call average. Median and mode, well, there are functions that we have written in the past that do these. We wrote a mode function. It's in the list chapter. Um, well, I don't know if it's in the list chapter, but we did it. I think it's before, actually. The mode is the value that occurs most often. The median is the value that's halfway in between. Once you've actually ordered your values, say, from least to greatest. So that obviously happened in the lists chapter because you had to order the list, and then once you had ordered the list, it becomes an easy matter to find what the median is. So there is code that will do this back in previous chapters, and of course you didn't delete any code, so you can just go and grab those functions. And what you find below is my output file for that sample gradebook that I gave you. And again, the standard will be that you get this character for character the same as what I have. Okay, and there also is my analysis. All right, so let's go back and actually look at the code that I gave you. This is just a little bit of hopefully helpful code to get you started. Okay, so line number 8 is where this really begins. Line number 8, I open the file. The name of the file is class_data.txt, and the R indicates that this will be read only. We intend only to read. So we open it, and then we assign the open file to the variable data file. So data file, that variable now points at the open file, which means that we can now use data file, that name data file, to read data out of the file. So data file.readLine reads a line. And you could think of this as like a pointer that initially points at the first character, 0th character in the 0th row, and then you read a line, and now the pointer is at the start of the row 1 and so on. So I read a line, and I just printed it to show you that it actually works, and then I read it another line, and I showed you rstrip. And why would you use rstrip? Because if you go back and look at the data file, you will see that the text editor doesn't put everything on a single line, but instead jumps to a new line. And you know how this works, right? The way that the text editor knows to jump to a new line is that it encounters the characters \n. Okay, when it sees the backslash, it goes, "Hey, now something special is about to happen," and then the character that comes after the backslash defines what that special behavior is, which is the n, which is the new line. So what that really means is that in the file as it's stored, there's a \n at the end of every one of these lines. And when you do the read line, you get that. Okay, that'll be the last character in the line is \n. But you don't want that. That's not data. That just determines how it is that the data will be displayed. And the rstrip is like, it's like Python's answer to this potential issue. It just strips off everything that is counted as white space at the end of a string. Those could be spaces, those could be tabs, or that could be a new line. Okay, so it automatically gets stripped off, and then you have to close as well. Now, of course, you have to read all the lines in the file, right? So you can just continue to read until you are done. And if you'd like a reminder about how you would know that you were done, you can go back to the strings and files chapter if you like. There's another way that you can do this as well. Maybe I should have included sample code for this too. But this is discussed at the end of the strings and files chapter. Python also allows you to iterate through a file with just a simple for loop. So it's just something like for a line in the file name, okay? And then that will give you the successive lines, and you can rstrip them, and they have the data in them, and then you've got to go in, of course, the line and pull the names out and the numeric data and all that. So maybe a for loop is actually the best way to do this. And then the second part of your task is this. I guess I think of this as like 3-part. Read the data in, analyze the data, that is, perform the computations, which means that you produce presumably a dictionary with all the averages, and then write that to an output file. Well, how does this work? I wrote a little bit of code that just writes a bunch of random numbers to the file to give you an example of what this looks like. So it's called new file. It's created on line number 24. The W is the second argument. Of course, the first argument, randomlines.txt, that's the name of the file. The second argument, the character W, indicates that we mean to write to the file. And then the code just produces a bunch of random lines of numbers. And then the important line of code is line number 33, new file dot write. This line is the line that I built up, and then I want it to display in such a way that after I write a line, if I view it in the text editor, if I view the file in the text editor, it will go to the next line instead of just concatenate everything on a single line. The way you do that is you just add in the \n. And then if you were to run this, and if you look over in the console, you can see that I actually did read in the first two lines. The initial line is the header line that defines the categories. And then I got a line of actual data. And then also, if you look on the left-hand side, there's a new file. And the new file is just a number of lines of random numbers, okay? And the reason that it is displayed with new lines is because, I concatenated in the \n. So that's the description of the project that you're supposed to do, okay? So how you actually structure this, what the functions are, that's up to you, If you want to write one massive function, or here's a totally awful decision, write no functions at all. Just put all of your code in global scope. Just don't do that. Or write just one function that's 120 lines long or whatever. Don't do that either, okay? Think about what the individual tasks are and write a function to perform each individual task. I presume there would be one that would read the file and create the dictionary that contains the data in the file. Or maybe just a function that just reads all the data in string form. Okay, maybe a list of strings or something like that. And then a second function that takes that list of strings, each of which is a line, and then chops it up and pulls the data out of it, right? And then maybe another function that actually computes the averages. And then maybe another function after that that takes the data that's been computed and writes it to a file. But that's part of what I expect you to do, is to think about how it is that you should chunk this project up into individual tasks so you make your life as simple as it possibly can be. But if you do want to make your life as hard as it can be, don't chunk it up like that, okay? And what that will mean, of course, is that when inevitably it doesn't work, it will become very difficult, or potentially very difficult, to figure out why precisely it doesn't work, where exactly it goes wrong. Chunk it up into functions. As best as you can, make each function perform one task. And then, of course, as functions get written, test them out to convince yourself that they actually do work. That's how we proceed in this class. Okay, so that's it. I'll go ahead and shut up. And then probably, at least for 1 or 2 days more, I'll need to come in and just sort of remind you where you are at and what it is that you need to do. And we will absolutely, maybe 2 days before the project is finally due, we'll pretend that it is due on that day, and we'll just go through the process whereby I'll get a grade, so you'll understand how that works.